Hello everyone, this is our final project for the subject 5373 Advanced PLC, which is taught by Professor Nathir Rawashdeh, and we have done this project called Cooling Control System. So let's get started with the system. So this is the PLC that we are using. We are using Compact Logic's L23E QBFC1B, and this is the hardware setup that we have done for our project. Here is our control panel. There you can see we have tagged it all the way through. You can see we have kept signal wires and supply wires different so that signal should not interface while traveling from PLC to the hardware part. This is the HMI we have created with Ignition SCADA software to control the whole program. So let's get started with the working demo of this project. So here is our HMI panel. You can see we have start, stop and reset button, as well as the actuator indicator, status lights and schedule indicator as well. So we can see we have low cooling, medium cooling and high cooling. So what does it really means? That if we are running low cooling, then we are running things on 33% duty cycle. If it is medium, it is 50% duty cycle, and if it is high, it is 66% duty cycle. So now we are selecting low cooling schedule, and now when I'm putting HMI start button, it starts the conveyor, and now we can put the component. So as you can see, this component is clicking this limit switch, which is then triggering a timer, and after the timer ends, the actuator is pushing that component into the cooling section. So now my cooling chamber shows that it is on 27.1 degrees Celsius, which is the ambient temperature. But as soon as the component comes, the temperature starts rising. So you can see. So we have given this time delay so that by that time it can reach up to the actual temperature of the component. So it is 37.2. So now, as I told you that we have started the low cooling schedule, we can see the results. So now we will be getting a low cooling drop, and just like this, if we are setting it on 50% duty cycle, we will get a comparatively faster cooling rate, and if we are setting it on high cooling rate, then we will be getting a faster drop in the temperature. So this is just an example how we can play with the timers timing, so on and off of the fans, and we can manipulate the temperature drop or temperature drop rate for the different components or different materials, because temperature drop really matters with the properties of the component. And as you can see, by now it has reached 33.5 degrees Celsius. So the total time span of this cooling chamber is for now kept for 5 minutes, but we can vary it, and now we have given it like 2 seconds on and 4 seconds off. So total I can say 33% duty cycle, because it is kept on low cooling. So now as you can see, our temperature sensing time is about to end, and as soon as it will reach to 5 minutes, we can see that the fans will stop working. So now this is end of the fan. So as we can see, our cooling session is about to end, and we can see that the temperature has dropped for 29.5 degrees Celsius, and the actuator has started advancing towards the part to push it out, because it is cooled now as per the schedule. So now the part is out of the cooling session, and our conveyor will be started just after this actuator retracts to its original position. You can see. So this is how the loop will keep on working until we check on for any other cooling schedule. So this is how our project works. Thank you.